Find the roots of z to the power of 24 is 1, which satisfies the condition argument of z is greater than 0 and less than pi over 2. Expressing your answers in the form r multiplied by e to the power I theta, the Euler's form. To find the roots, we need represent a given complex number in the Euler's form r multiplied by e to the power I theta firstly, and how to represent just one in the Euler's form. One is here on the organ diagram. And what is modulus? Modulus is distance from the origin, or you may just apply a formula, square root of x squared plus y squared, where 1 is just 1 plus 0i. And angle is 0 because starting point for angles is here. So 1 is just 1 multiplied by e to the power I 0. And notice that if you meet that to some power is negative 1, it's not correct to write negative 1 multiplied by e to the power I 0, because modulus cannot be negative. And how to represent negative 1 correctly? Negative 1 is here, distance from the origin is 1, and angle is pi or 180 degrees. So negative 1 is 1 multiplied by e to the power I pi. So z to the power of 24, it's 1 multiplied by e to the power of I 0. And to find the required roots, we apply a formula. Zk is modulus to the power 1 over 24, or root of degree of 24 over the modulus, and multiplied by e to the power of I theta k, where theta k is our angle is 0 divided by 24 because z to the power 24 plus 2 pi k divided by 24. K is 0, 1, 2, and so on up to 23, so that there are 24 roots in total. If you consider that 24, it will be this root corresponding to k is 0, but rotated by 360 degrees, and it will be absolutely the same complex number. And we need roots from a given region, and let me write pi over 2 as 12 pi over 24 to be more useful. And we can see that possible roots are, when k is 0, we can see that it becomes 0 plus 0 is 0, but argument of that is strictly greater than 0, so it's not a root. When k is 1, it becomes 0 plus 2 pi over 24, it's a root. 1 to any power, it's 1, so the first possible root is 1 multiplied by e to the power of I 2 pi over 24. I will not simplify, I will keep a common denominator 24. The next possible root is when k is 2, so it's 1 e I 4 pi over 24. When k is 3, it's 1 e I 6 pi over 24. When k is 4, it's 1 e I 8 pi over 24. When k is 5, it's 1 e I 10 pi over 24. When k is 6, it's 12 pi over 24, but it's strictly less, so it's not a root. And we can see that there are 5 roots in total. B. Let S be the sum of the roots found in A, so it's just sum of these values. Show that the real part of S is equal to the imaginary part. And we know that r e to the power I theta is r cosine theta plus I sine theta. So the real part is just r cosine, the imaginary part is just r sine. And hence we can write that it becomes the real part, it's just the sum of cosines, but let's simplify and let's write all with common denominator 12, so it will be and we cannot write modulus which is 1, and hence it becomes just cosine of pi over 6 plus cosine over cosine of pi over 12 plus cosine of 2 pi over 12 plus cosine of 3 pi over 12 plus cosine of 4 pi, or pi over 12 plus cosine of 5 pi over 12. And imaginary, it will be sine of pi over 12 plus sine of 2 pi over 12 plus sine of 3 pi over 12 plus sine of 4 pi over 12 plus sine of 5 pi over 12, and everywhere r is 1 and we don't write 1. So I write quickly, that is cosine pi over 12 plus cosine 2 pi over 12 plus cosine 3 pi over 12 cosine 4 pi over 12 plus cosine 5 pi over 12. And the imaginary part is sine pi over 12 plus sine 2 pi over 12 plus sine 3 pi over 12 plus sine 4 pi over 12 plus sine 5 pi over 12. And we need to show that this is equal to this. How to do that? We know the next properties. For example, sine 30 is the same as cosine 60, or sine of 90 degrees, or pi over 2 minus alpha, it's the same as cosine alpha. So if we consider, for example, cosine pi over 12, it's the same as sine of 90 degrees, or pi over 2 in radians, but pi over 2, it's 6 pi over 12 minus 5 pi over 12. So it's a sine 90 degrees minus alpha is the same as cosine, just no, it's sine, it's cosine pi over 12, it's cosine, just to get pi over 12 here, it's 90 or pi over 2 or 6 pi over 12 minus 5 pi over 12. Yes, it's just the same, but pi over 12 is represented as 6 pi over 12 minus 5 pi over 12, and it's sine of this. So cosine 90 minus alpha, it's sine alpha. Yes, now it's correct. So this is equal to this. And absolutely similarly for other terms. Let's consider one more. Cosine 2 pi over 12, it's cosine 6 pi over 12. To get 2, it must be 4 minus 4 pi over 12. It's just the same. And cosine 90 minus angle, it's sine minus this 4 pi over 12. So this is equal to this. And absolutely similarly for the remaining terms. So hence the real part is equal to the imaginary part as required. The next, by writing pi over 2 as pi over 4 minus pi over 6, find the value of cosine pi over 12 in the form by writing not pi over 2, pi over 12. Yes, common denominator is 12. So it's 2, no, it's 3 pi minus 2 pi. Yes, it's pi over 12. So let's consider cosine of pi over 12 as required, so it's cosine of pi over 4 minus pi over 6, and we need the exact value, not rounded value from the calculator, over cosine of pi over 12, and hence we represent it as cosine of the difference, but we know formulas for sum or difference of cosine of sine, and formula is given in a data booklet, and cosine of the difference is cosine cosine plus sine sine, so it's cosine pi over 4 multiplied by cosine over pi over 6 plus sine pi over 4 multiplied by sine over pi over 6. Pi over 4 it's 45 degrees, pi over 6 is 30 degrees, for 30, 45, 60 degrees we know the exact values for sine cosine. So cosine of pi over 4 is root 2 over 2, cosine pi over 6 it's 30, it's root 3 over 2 plus root 2 over 2 multiplied by a half, and common denominator is 4, so it's root 6 plus root 2, and it's the value of cosine of pi over 12. Hence, otherwise show that as is, as it's a complex number, which is the sum of these roots, and as it will be 1 sum of cosines plus sum of sines, but since real part is equal to imaginary part, we can, as finally becomes all this real part plus I, and again the same, which is real part, because imaginary part is equal to the real part, and we can see that we can factor out the real part, this sum of cosines, so it's cosine plus cosine plus cosine, and it will be multiplied by 1 plus I. So we need just, or actually it may be imaginary plus imaginary here, it doesn't matter, because this sum for cosines is equal to the sum of sines, but since we have found cosine, let's use cosines. So we need just find this value, the sum of cosines, and cosine of pi over 12 is found. 2 pi over 12, it's pi over 6, it's it's 30 degrees, there is an exact value. 3, it's pi over 4, also there is an exact value, it's pi over 3, it's 60 also, there is the exact value, and we need the exact value of 5 pi over 12. 5 pi over 12, and we can use the same formula, I mean similar expression, and we can write the next cosine of 5 pi over 12. You can notice that it's cosine pi over 4 plus pi over 6, and common denominator 12, it's 3 plus 2, so it's 5 pi in total, so it's correct. And apply formula for this sum for cosine. The formula is given in a data booklet, and it's cosine cosine minus sine sine, so it's cosine pi over 4 cosine pi over 6 minus sine sine, so minus sine pi over 4 sine pi over 6 and cosine of pi over 4 is root 2 over 2. It's pi over 6, it's 30, it's root 3 over 2 minus root 2 over 2 and multiply by a half, so common denominator is 4 and it's root 6 minus root 2 and hence as becomes cosine of pi over 12, which is root 6 plus root 2 over 4, and let write plus cosine 5 pi, which is plus root 6 minus root 2 here, and plus cosine of pi over 6, it's 30, it's root 3 over 2, plus cosine of pi over 4 is root 2 over 2 plus cosine over pi over 3, it's 60 degrees, it's a half. And you remember that it's the sum of cosines multiplied by 1 plus I, and it becomes, we can see that it cancels, it's 2 times root 6 divided by 4, it's root 6 over 2 plus root 3 over 2 plus root 2 over 2 plus a half multiplied by 1 plus I. And what do we need? We need a half. Actually we can expand this and show that it is equal to this, or we can do the next. So it's a half root 6 plus root 3 plus root 2 plus 1 plus I. And actually you may just expand this, and if you can see that when it is equal to this, you may just directly write that it is 1 plus root 2 multiplied by 1 plus root 3 as required. Or how to get it from the sum of 4 terms? Definitely we need factor out something, and we can see that root 6 it's root 3 times root 2, and we can combine and it becomes root 3 root 2 plus 1 plus root 2 plus 1, and now it becomes, we can factor out root 2 plus 1 and it becomes root 3 plus 1, and we get an expression as required. Yes, it's correct. And that's all for this question.